In this section, we're going to study the coordinate plane. So this is something that is very familiar to you, but we are just going to define some additional concepts to it. So for example, we have the x-axis, which is always horizontal, where the positive values are on the right and the negative values of x are on the left. And we have the y-axis that runs vertically, and we have the positive values on the above the x-axis, and we have the negative values below the x-axis. Then this is dividing the space into 4 areas, but these areas are unlimited going this way. So this is just remember that the space is unlimited, but these 4 areas have boundaries on these sides. Now this one is going to be known as quadrant 1, and then we're gonna go counterclockwise, meaning this direction, to name the rest of the quadrants. So this will be the second quadrant, this will be the third quadrant, and this will be the fourth quadrant. This is going to be important information when we study trigonometry. And then for every point on the plane, we always need 2 numbers. The first number that we have for every point is going to be known as the x-coordinate, and then the second number that we have is called the y-coordinate. And this pair of numbers that are a characteristic of every point is called order pair. And it's called order pair because the order matters. If I say 0, 2 and 2, 0, those are different points. So the order in which the numbers are written matters. That's why it's called order pair. On this section, it says graphing regions in the coordinate plane. Regions meaning different areas in the coordinate plane. These squiggly marks in here are called braces, and they denote sets. Set meaning a collection of things. So this is saying shade me all the points on the coordinate plane, and this is, you know, your order pair. So it implies that you have points. I'm just reading this off so that you know what the meaning of it is. And this symbol means such that. So I want you to shade on the coordinate plane all the points that follow the following condition. It says all the x-coordinates should be greater than or equal to 0. So let's just have a few points on the quadrants, on the different quadrants, and let's see what that means. So I don't know, let's say this is the point 1, 6, this is the point, I don't know, negative 2, 4, this is the point negative 3, negative 4. I'm just picking some random order pairs. The only thing that I'm choosing is just the right sign. A point here is going to have positive x-coordinate and y-coordinate. A point in here is going to have a negative x-coordinate but a positive y-coordinate. A point here is going to have negative x and y, and a point in here is going to have a y next positive but a y that is negative. So what does that mean to shade all the points for which the x is positive or 0? So for example, look at the points that are over here. Both x's are negative, so that means I should not shade anything on this area, because for quadrants 2 and 3 all the x's are negative. So that makes me shade everything in here. So you will shade it if you have a color pencil, or if you have a pen like me, it's enough. I mean, it is understood that you're shading that. And then x can also be 0, so you are saying that you're included all the points on the y-axis, because points on the y-axis have x is equal to 0. I don't know, this could be 0, 1, this could be the 0, 2, and so on. So all the points on the y-axis has x-coordinate 0. And since x equals 0 is admissible here, because this is read as greater than or equal to 0, that's why I'm shading as well the y-axis. For part B, I want to shade all the points such that the y equals 1. So on my coordinate plane, I'm going to shade all the points for which the y is 1. So let's have some examples. The point 0, 1 has y1. The point 1, 1 has y1. the point 2, 1 has y1. So 0, 1 is here, 1, 1 is here, 2, 1 is here. So all the points for which the y coordinate is 1 happen to be lined up. So these are all the points. Okay, and now for part C, it says I want to shade all the points on the coordinate plane such that the absolute value of y is less than 1. So remember from what we have seen in the past section, absolute value of y less than 1 means y is going to be between negative 1 and 1. So what are all the points for which the y coordinate is between negative 1 and 1? So I know that the ones that have coordinate 1 are these. So the ones that are going to have coordinate negative 1 are going to be lined up on a line like this. So that means the points that have y between negative 1 and 1 are going to be the ones shaded in between. But what's going to happen? The only thing that you have to be careful here is that the points that you're going to shade are in between those lines, but that does not include the line itself. So I'm going to draw a line through 1, but is a line that is dashed to indicate that I'm not including the points on this line and I'm not including the points on this other line, but I'm shading everything else in between. If this was, what if it was like this, negative 1 less than y or equal to, and y less than or equal to 1, then I would have to make this line solid just like I did in this example, and then shading everything else in between. You don't have this on your slides, but let me just point out that you can also use intuition to find the distance between 2 points besides using the formula. We will use only the formula when we want to express an equation in terms of another variable, or when we don't have graph paper. But other than that, if we have graph paper, if we have a picture, then let's just use common sense. So what is the distance between the point A and B? And as you can see, it is easy for me to construct a right triangle and apply Pythagorean theorem, and then find out what the hypotenuse is, because the hypotenuse is what represents the distance between A and B. So the distance between A and B, and this is how I will write it, distance in parentheses, and the points are going to be written in capital letters, and the distance will be here 3 square. This is 3 and this is 3, and this is, I don't know, this is the distance that I'm looking for. 3 square plus 3 square, and I'm going to take the square root of that because that's what I would do when I apply the Pythagorean theorem. Now remember that when you have the Pythagorean theorem, a squared plus b squared equals c squared, this applies for any b, a, b, or c. But since we're talking about distance, this c is always positive, so I don't have to worry about the 2 answers that I will get out of this. I just worry about the positive ones because I'm talking about distance. So in here, this would be a square root of 3 squared is 9 plus 9 square root of 18. And that will be the distance. That means that if there are 3 squares in between these 2 points, between these 2 points I have a square root of 18 squares. Okay, which is about, and then you will take the square root of that, which is 3 point something something. Let me find the square root of 18. Oh, sorry, 4.24, and it's bigger than 4 because you know that the square root of 16 is 4, so a square root of 18 has to be a number bigger than 4. So let's use Pythagorean theorem whenever we have a grid like this. Oops. Now this is my right triangle, and then if I'm trying to find the distance between C and D, then it's just the square root of 2 squared plus 1, 2, 3, 4, 5, 6. 6 squared, and that would be 4 plus 36, square root of 40. And then which is approximately 6.5 32.4, and I'm writing it with squiggly equal signs to say approximately, but the exact distance is a square root of 40. So what happens if I have to find the distance between 2 points and I really don't know where my coordinates are? Well, I still can use a triangle, a right triangle. I just have to know what it is that I'm doing to find how big the legs are. So for any 2 points A, B, with some coordinates, and I'm calling them x1, y1, and x2, y2, just to say that these two are points that are different on the space, not that they are the same point. That's why the x cannot match it and the y's cannot match. How would I find the measurement of this length right here? Well, if I know how high the point A is and how high the point B is, then I can just find the difference of that. So I will have to find how much is yy minus y2. But in this general case, I cannot guarantee that B will be lower than A. Maybe is A over here and B over here. So that's why I'm taking absolute value, because I want to say that whatever difference you find, it has to be a positive number, because the length of a leg is a positive number. So the same idea here. How do I find how far away A and B are? Well, this is just the difference of the x coordinate. So x1 minus x2. But I'm going to take the absolute value of it because I want this difference to be always positive. And it may or may not be the case depending on the coordinates of A and B. So the distance between A and B will be the square root of the difference of the x's, x1 minus x2 square, plus this other leg, which is absolute value of y1 minus y2 square. Now, what happens when I'm squaring a number? When I square a number, the answer is always positive. So I don't have to worry about the absolute value anymore. I can just write it with parentheses, because I know even if this difference is negative, when I square it, I will make it positive. And that's how we come up with this formula for distance. This is just an abbreviated version of it, and this is something that I would like you to write down when you see your formula, is the square root of the difference of the x's square plus difference of the y's square. This triangle is not a triangle, is a Greek letter that is called delta. You know of Greek letters from movies about fraternities and colleges. This is the letter called delta, and it means difference. So I want to know how apart the x's are, how apart the y's are, and those are going to be the length of my legs to apply Pythagorean theorem and finding the distance between 2 points.